Laser stands for light amplification by stimulated emission of radiation, a special type of electromagnetic radiation. In many scientific, military, medical and commercial laser applications have been developed since the invention of the laser. Frequencies are emitted with large spectral width in all directions from the incandescent light. But from a laser device, frequency emitted with narrow spectral width, only at a certain direction. In sunlight many colors as well as frequencies are present. In LED lights, only one color is present. But if we look into their wave diagram, we get the waves are not in phase. Whereas in laser, we get monochromatic waves in phase. That's why it is very energetic and intense. Relatively small amounts of laser light can lead to permanent eye injuries. Moderate and high-power lasers are potentially hazardous because they can burn the retina, or even the skin. Many scientists involved with lasers maintain some precautions. Protective eyewear in the form of appropriately filtering optics can protect the eyes from the reflected or scattered laser light with a hazardous beam power, as well as from direct exposure to a laser beam. One might begin the history of lasers with Albert Einstein. In 1917, he develops the concept of stimulated emission on theoretical grounds. During the Second World War, the attention of the technical community was diverted in large measure into the microwave region of the spectrum. In 1954, a device called the maser, standing for microwave amplification by stimulated emission of radiation, was developed by Charles Townes and his co-workers. The maser was the forerunner of the laser, inspiring theoretical work by Townes and Arthur Leonard Shallow that led to the invention of laser in 1960 by Theodore Meiman. Stimulated emission is the phenomenon that is utilized in lasers. Einstein showed that emission of light could be triggered by an incoming photon if an electron were present in a state with high energy, and the photon must have the proper energy corresponding to the energy difference between the original state and the lower energy level. Gain medium of a laser is that part where the atoms are present, which are to be excited. Pump source is the energy source which is used to excite the atoms. After few moments, the atoms are coming to their original state through emitting radiation. This radiations are reflected by the reflector, and we get the laser light from the partially reflecting mirror end. Laser produces a single wavelength with one color. This is known as monochromaticity. Two kinds of coherence observed. First one is the spatial coherence, related to the space. And the last one is temporal coherence, related to the time. Highly collimated and non-diverging property of the laser beam makes it very unique. Lissing material, pumping system, optical cavity are the three major components of a laser. Solid-state ruby laser was the first laser. Then helium-neon, a 4-level gas laser, comes up with red color. Carbon dioxide laser is the most powerful gas laser, comes with versatile applications in many fields. The worldwide requirements of semiconductor lasers are increases day by day due to its potentials. Along with the many chemical lasers also developing in many countries. Less than 1 kilowatt energy laser is used to destroy sensors. More than 10 kilowatt energy laser is used to destroy electro-optic devices. And more than 100 kilowatt energy laser is used to destroy structure of materials. The coherency, high monochromaticity, and ability to reach extremely high powers are the properties which allows in applications in different branches of science and technologies. In material processing, lasers with average optical power above 1 kilowatt are used mainly for industrial materials processing applications. Laser systems in the 50 to 300 watts range are used primarily for pumping, plastic welding and soldering applications. Lasers above 300 watts are used in brazing, thin metal welding, and sheet metal cutting applications. Military uses of lasers include applications such as target designation and ranging, defensive countermeasures, communications, and directed as in energy weapons. Laser communication in space is the free space optical communication. With a range of several thousand kilometers, it's suitable for inter-satellite service. It has the potential to bridge interplanetary distances of millions of kilometers. Medical lasers are designed to the energy emission. Strong emissions are used in surgery, to cut effective tissue. Medium emission is used for deeper tissue treatment. Soft lasers are used in dermatology, angioplasty, cancer treatment, dentistry, dermatology, lithotripsy, laser mammography, medical imaging, optogenetics, prostatectomy, plastic surgery, and many others. Applications stimulates the use of medical lasers. Laser technology is a staple of science fiction and our daily lives. This 60-year-old technology continues to improve, and engineers are still developing brand new applications for lasers. Lasers are used in medical procedures, beauty treatments, telecommunications, industrial applications, robotics, autonomous vehicles, toys, scientific research, and more. Due to their power and precision, lasers are also being developed for military use. There's a lot of interest in putting lasers on a wide variety of platforms to defeat a really wide variety of targets.